Hi, I'm at the MathCraft MathLab. I'm Dr. Curtis, and today we're going to solve linear equations. A linear equation is an equation that contains one or more variables and other numbers or quantities. In this example, we have the variable x, the number 5. In the example below it, we have the variable y, the number 4, and the quantity 40 pounds. The first example of a linear equation is already in the form of a solution, since the equation itself tells us that the value of the variable x is 5. Let's take a look at the next one. It tells us that 4 times some unknown value that we'll call y is equal to 40 pounds. In this term 4y, the number 4 is what's called the coefficient. To solve for the variable y, we want to change this equation so that the variable is on one side all by itself. What kinds of changes are okay to make? Well, we can do anything to the equation as long as we do the same thing to both the left side and the right side. In this case, since we're trying to get the variable y by itself, the best thing to do is to divide each side by the coefficient 4. So let's do that division now. We'll divide 4y by 4 and 40 pounds by 4. 4y over 4 is the same as 1y over 1. And 40 pounds over 4 is the same as 10 pounds over 1, since 40 divided by 4 is 10. After cleaning it up, we get y equals 10 pounds. Notice we don't have to include the 1 here, because 1 times y is just y. Here's another example. This equation says that 6 plus 5 is the same as the unknown value z minus 7. Sometimes you may be given a linear equation in which the left or right side, or even both, has some arithmetic that can be done. Obviously, we can't add z and 7 until we know the value of z, but we can add 6 and 5. Usually, it's easier to take care of this first, before deciding what operation to do to both sides of the equation to get the variable by itself. So 6 plus 5 equals 11. Now remember, the coefficient for z here is 1, so we could divide each side by 1, but that wouldn't really change the equation. However, you can see that if we added 7 to each side, we could simplify the arithmetic, and the variable could be by itself. So 7 plus 11 equals z minus 0, because 7 plus minus 7 is 0. We can remove that, and now we have the z all by itself. We're not done because there's still more arithmetic to do. 7 plus 11 is 18. And now we know the value of z, 18. So were we right? Well, we can actually check. Let's go back to the original equation, and let's plug 18 in for the variable z. If the result is a true statement, then we know we did it correctly. So again, 6 plus 5 equals 11. 18 minus 7 equals 11. 11 equals 11, that's true. Z must equal 18. Here's one last example that requires a few more steps. The variable x has a coefficient 3. We could divide both sides by 3, but neither 16 nor 49 are evenly divisible by 3, so that would be less efficient than the other alternative, which would be to subtract 16 from both sides. This makes progress towards the solution because it reduces the number of terms on the side of the equation containing the variable. course, we don't need the 0, so we can eliminate that. What we get is 3x equals 33. Now the example looks a lot more like the first one that we went through. We can divide each side by the coefficient 3. And so x equals 11. I'm Dr. Curtis. I'll see you next time.